Go. Your gas laws page might not look just like this, but you do have this page. So go on there and let's do some of these practice problems. Gas laws are pretty simple relationships. They each have two variables. We've got one for pressure and volume, one for pressure and temperature, one for volume and temperature, and one for volume and the amount of substance. Now, the good news is it really doesn't matter which unit you're using as long as it's the same before and after. There's only one exception to that. It is temperature. You must use Kelvin. None of these work in Celsius. If you don't believe me, we've already done questions, let me zoom out a little bit. We've already done questions 1, 3, and 5, and if you need some help figuring out what's going on here, you can pause this and take a look, but let's take a look together here at number 3. Number 3, a 375 milliliter sample of nitrogen is kept at a constant temperature. Okay, they mentioned two things already. Milliliters and temperature. Milliliters means volume. Okay. But constant temperature means there isn't a change there. So temperature might not be my second variable. I'm going to keep reading. It has a pressure of 1.2 atmospheres. Okay, there we go. So I've got volume right here, and I've got pressure over here. So what I did here, I've got volume 1 is 375 milliliters. Volume 2 is 125. So that's what's going to fill in for volume 1 and volume 2 over here. And then for pressure, the original pressure was 1.2 atmospheres, so that's what pressure 1 is going to be over here. And I don't know what pressure 2 is. So I'm going to solve. Okay, set it all up, divide this side by 125 so I can get the variable by itself, and there's your answer. All right, if that didn't go slow enough for you, that's okay. I want to do a couple together anyway. So let's zoom down here and pick one that's a little trickier. Let's pick something, let's pick something down here. Let's do number 6. Something with Kelvin. So a sample of argon gas has a volume, okay, here volume, so I know already I'm going to have V1 and V2, okay, sort of a volume before and volume after. Sample of argon gas has a volume of 6 liters at a temperature of 7 degrees Celsius. Okay, so I know I'm going to have a temperature 1 and a temperature 2. All right, let's see. 6 liters when the temperature is 7 degrees Celsius, and it wants to know what's the volume when the temperature is 147 degrees Celsius. Well, here's the problem. I do know what relationship, what gas law I need. I need Guy-Lussac's law. Wait, did I lie to you? Volume and temperature. I lied to you. I need Charles' law. There we go. So Charles' law is what we're going to use. I want you to pause this here and try to set it up. All right, so there's Charles' law. Pause it, set it up. Here we go. Now, we have a problem right off the bat. These are in Celsius. We cannot put Celsius in here because Celsius is a scale that goes negative. We need a scale where 0 is the lowest number we can go, and that is Kelvin. So, good news is if you want to go from Celsius to Kelvin, all you have to do is add 273.15 degrees Kelvin. 273.15, that should say degrees Kelvin. Let's go ahead and get our calculator out and add that. 7 plus 273.15. Okay, so our actual T1 is going to be 280.15 Kelvin, and our actual T2 is going to be, let's see, 147 plus 273.15, 700.3. Wait, that can't be right. Did I type something wrong there? 147 plus 273.15. There we go. I don't know where I got 700 from. You know, because you can see in the past, but I can't. So here we go, 420.15. All right. So now that we've got our numbers, V1, we don't know V2, temperature 1 and temperature 2, let's plug them in. So V1 is going to be 6 liters, and I'm writing the units just out of habit. It's a good habit to get into. It means you won't forget your units very often, but it won't affect the math at this point. Okay, over temperature 1, that's going to be 280.15 Kelvin. And I know that that's going to be equal to V2 over temperature 2. We don't know V2, that's our X in this problem. But temperature 2 is 420.15 Kelvin. You don't have to write the parentheses. Again, that's just a habit that I've gotten into because as you go down the line in chemistry, you'll need sometimes to leave things in parentheses to make your life easier. At this point, you don't really need to. All right, so how do we solve for X? Well, multiply both sides by 420.15 so that this will cancel out and we'll get X all by itself. Okay, so let's see what happens when we do this. We've got, put my calculator where you can see it. We've got 6 divided by 280.15 times 420.15. All right, what do we get for that? 8.998. What are our units on that? Well, this was Kelvin and this was Kelvin, so those are going to cancel out and we're left with liters. That's just a way to check that you did it right. It's equal to X, and that was our V2. So that should be our second volume there. So if you're having trouble on a couple of these, questions 1 through 10, check to make sure you're using Kelvin. All right. The rest of these are pretty much exactly like what I just showed you. It's just your job is to find the variables. Are we working with pressure and temperature, volume and the amount of substance, volume and temperature, pressure and volume, and then just plug them in and solve for whatever the fourth unknown thing is. So there we go. I hope that was helpful. Please don't go past 11 until you've learned about the ideal gas law. Or sorry, don't go past 10 until you've learned about the ideal gas law. And shall we just check our answer here just to be fun? Okay, we decided 8.998, and you don't have to write liters because it's already there. Let's check it. My score is 0%. Did I round wrong? What do you mean my score is 0%? Should I round to 9? Is that what they want? What? Did I make a mistake here? Oh no, I got it right. There we go, 9 liters. Okay, so they just wanted you to round. Whew. It was a scary moment for me.